We are now on part 2 of the 27th PMO qualifying stage. Problem number 1. Let O be a circle centered at the origin and whose radius is an integer. Furthermore, the points -1, -1, -2, 3, and 4, -5 are inside this circle. What is the smallest possible diameter of circle O? Let us plot first the 3 points and then connect each point to the origin. Now, in order for the 3 points to be in the interior of circle O, the circle must have a radius that is longer than the longest segment. You can easily verify using the distance formula that the longest segment, this one, measures square root of 41 or approximately 6.4. Since we want the smallest possible diameter for the circle, we choose the smallest possible radius for the circle. So obviously, since the longest segment is 6.4, we must choose 7 as the radius of the circle. So the smallest possible diameter of the circle that encloses all these 3 points is 14 units. So the answer is letter C. Problem number 2. How many ways are there to place 3 identical coins in a 4x4 chessboard such that no 2 coins are on the same row or the same column? Let us determine first the number of choices for the placements or locations of the 3 identical coins. Since the chessboard is 4x4, it has 16 squares. Let us label the squares using letters from A to P. Since we can place the first coin in any square, there are 16 choices for the first coin. Now suppose that square F is chosen as the location of the first coin. So automatically the squares above, below, to the left, and to the right of square F are excluded as options for the location of the second coin. So we are left with 9 options for the second coin. And suppose that square K is chosen as the location of the second coin. So we also exclude the squares above, below, to the left, and to the right of square K. So we are left with 4 options for the third coin. And for illustration purpose, let us say square M is chosen as the location for the third coin. Now, the product of these 3 numbers does not actually give us the correct answer because it accounts for the permutations of the chosen squares in the board. So we have to divide this one by 3 factorial or 6. To illustrate, let us take this specific case as an example. Instead of selecting F first, it is actually possible that K is selected first and then followed by F and then by M. It is also possible that M is selected first, followed by K, followed by F, and so on and so forth. So we are actually arranging the chosen letters in 3 factorial ways, right? So we have to divide 576 by 3 factorial or 6. So the final answer must be 576 divided by 6, which is equal to 96, and that is letter C. Problem number 3. A positive integer is called goofy if its third smallest positive factor is 5. How many 2-digit goofy numbers are there? Rather than identifying directly those numbers that satisfy the given condition, we can actually generate them by starting with the product of smaller factors. That way, the process is much easier. For example, we can start with the product of 1, 2, and 5. The product is 10. Obviously, the third smallest positive factor here is 5. Now, how do we build the next number? Is it possible for us to insert another factor of 2? So if we insert another factor of 2, the third smallest positive factor actually changes. It becomes 4. So we cannot introduce another factor of 2. Now what if we replace 2 by 3? So we have this number. 1 times 3 times 5, which is 15. And obviously, the third smallest positive factor of 15 is 5. So this number satisfies the given condition. Another possibility is that we can insert another factor of 3. This does not change the third smallest positive factor because by inserting another factor of 3, we added a factor of 9, right? So 9 is greater than 5. So 5 is still the third smallest positive factor. Another possibility is that we can have 1 times 2 times 5 times 5, right? So that's equal to 50. Again, the third smallest positive factor of 50 is 5. Another is that we can also replace 5 by a factor of 7, and still the third smallest positive factor is 5. And the last case is 1 times 3 times 5 times 5, which is equal to 75. Clearly, 5 is still the third smallest positive factor. Okay, so there are only 6 two-digit numbers that satisfy the given condition. So the answer is letter D. Problem number 4. A drawer contains a number of shirts which may be red, blue, or yellow. If we choose shirts at random, the minimum number of shirts we must get so that we are guaranteed one of them is red is 8. Meanwhile, the minimum number of draws to guarantee a blue shirt is 7, and the minimum to guarantee a yellow shirt is 12. How many shirts are there in the drawer? Let us start by representing the number of red, blue, and yellow shirts by R, B, and Y respectively. Now let us focus on the second statement. If we choose shirts at random, the minimum number of shirts we must get so that we are guaranteed one of them is red is 8. So this means that in the first 7 draws, all blue and yellow shirts were already taken out. In other words, the total number of blue and yellow shirts must be 7. So we must have B plus Y equals 7. Now, similarly, in the third statement, the minimum to guarantee a blue shirt is 7. This means that in the first 6 draws, all the red and yellow shirts were already taken out. So the total number of red and yellow shirts must be 6. And by applying the same argument, we can determine that the total of red and blue shirts must be 11. So we have these 3 equations. So if we add these 3 equations, we must get twice R plus twice B plus twice Y equals 24. Dividing both sides by 2, we get the sum of R, B, and Y, which is equal to 12. And this is exactly the total number of the shirts. So the answer is letter A. Problem number 5. A laser is placed at the lower left corner of a square with horizontal and vertical sides. When this laser shoots out a beam, it will be reflected when it hits any of the 4 sides of the square. If the laser shoots out a beam with slope of 5/8 from the lower left corner, which of the corners will be hit next? Let's start by creating a square with vertices at 0, 0, 1, 0, 1, 1, and 0, 1. The quickest way of solving this problem is by tracing the path of the beam, but we have to be careful in doing that. We have to determine the points where the beam hits the side of the square. So how do we do that? Take note that the first beam starts from the point 0, 0, and it has a slope of 5/8. We can use this information to create the equation of the first beam. Now, the equation of the first beam is y equals 5/8x. We can use this equation to find the point that the first beam will hit on this side of the square. Now, we know that all the points on this side has x coordinate of 1, right? So we can just substitute x equals 1 in this equation to find the y coordinate. So we have y equals 5/8. In other words, the first beam will hit this point. This point has coordinates 1, 5/8. Now, let us determine the point on this side of the square that the second beam will strike. So how do we do that? Take note that the reflected beam will have a negative slope, right? So we can use the negative slope, which is -5/8, and then this point to create the equation of that second beam. Now, using the point slope form, the equation of the second beam must be y minus 5/8 equals the slope of -5/8 times the quantity x minus 1. So now, how do we determine the point where it strikes this side of the square? Take note that all the points on this side have a y coordinate of 1. So we can just substitute y equals 1 in this equation to get x. So doing that, we have x equals 2/5. So the second beam hits the point 2/5, 1. Alright, so we may not continue doing this because we can just use these first two beams to draw the other beams. We just have to make sure that the succeeding beams that we will draw are parallel either to the first beam or the second beam. Okay, so the next beam will be this one. So this beam is parallel to this. The next one is this one, which is parallel to this one. Next is this one. So this beam is parallel to this. And then next is this one. And then this one. And then this one. And then this one. And then the last one will strike the upper left corner. So the answer is letter A.